All right, guys. Questions on the homework? Okay. So up to this point, we've learned different ways to solve quadratic equations because we've gone over factoring, graphing, square root method are the main thing that we've had. Now with yesterday and the day before, our 3.4, we learned how to solve if we have to take square root of a negative number. Now the first property we have is this here, the square root of a negative number property. You don't necessarily have to write this down. The main thing is, if r is a real number, then the square root of negative r. I do not. I do not know.
He might be talking to the janitor. He had maggots in the room last
Yep. All right. All right, guys. So if we take the square root of negative r, we will get I square root of r. Now, if we square I squared of r, we get back to our negative r. We get back to where we started. All this is what we've been doing. If we take the square root of a negative number, the negative comes out as I. If we square that, we get back to our negative r. So, yeah, you're good? Because this is really talking about the fact that I, or going with our properties of I being the square root of negative 1. So if we take the square root of a number that is negative, the negative is going to come out as I times whatever our radical r is, our square root of r is. Now if we square I square root of r, we'll get back to negative r. Now up to this point, we haven't had to solve anything or haven't been able to solve anything where our solutions are complex numbers, have I as a part of the solution. And that's what we're really going to start off with today. All right, so when we look at this first one here, we want to solve x squared plus 4 equals 0. We want to solve this equation. Now, one of the methods we had for solving was graphing x squared plus 4. We put in the graphing calculator, we graph it, we see that it does not cross the x-axis, which does tell us by graphing we have no real solutions. And if it doesn't have real solutions, it means we cannot factor it. So these are not factorable. But since we don't have a middle term, we can get this equal to 0. Or we can get the x squared term by itself. We can use the square root method. Square root method, if we don't have a middle term, we get the square term by itself. So the first thing we're going to do is subtract 4 from both sides. Because our 4 minus 4 gives us 0, telling us x squared is equal to negative 4. Because at this point, the only method that we have for solving these equations that don't have rational integer solutions is the square root method. Since the x squared term is now by itself, we're going to take the square root. We're going to put a radical on both sides. The square root of x squared is going to be x is equal to plus or minus, because whenever we take the square root of both sides, we have to put the plus or minus. Now we need to take the square root of negative 4. Well, the negative part of this here is going to come out as I. Now what that leaves us with is the square root of 4, which is 2. So the square root of negative 4 is 2i. So it's telling us x is equal to plus or minus 2i. So our two solutions for this are positive 2i and negative 2i. And that's it. Now, if we wanted to check this here, we can check it in the graphing calculator. X squared plus 4, so the second quit. So we can say 2i squared plus 4 is 0. Negative 2i squared plus 4 is still 0. So 2i and negative 2i are our two solutions. Unfortunately, we can't graph and get to this here. It is possible to factor x squared plus 4, but in order to factor it, we needed to know that the factors of 4 that work for this here are positive and negative 2i. So we had to solve it to be able to factor it. But by that point, we don't need to factor it anymore. Questions on this here? 2x squared minus 11 equals negative 47. Again, we could try factoring and graphing it. It's not going to work for this here. But we can still use the square root method. And the reason we can use the square root method is there is no middle term. There is no x to the first power. We just have x squared. So our first main step in doing the square root method is to get the x squared term by itself. So we can add 11 to both sides. Yes, it tells us that 2x squared is our 11. Negative 11 plus 11 is 0, leaving 2x squared. Negative 47 plus 11 is negative 36. Now at this point here, the x squared term is not completely by itself, so we need to divide by 2. And our 2x squared divided by 2 is going to be x squared is equal to negative 36 divided by 2 is negative 18. Questions on what we've done so far? Is the x squared term by itself? X squared term, well, yes, it's by itself. There's nothing else with it. We do have the exponent. So since it is by itself, we can take care of that. We can square root both sides. Now the nice thing is, yes, square root of x squared is equal to plus or minus square root of negative 18. Well, the negative is going to come out as I, leaving us with square root of 18. Now, square root of 18 is not a perfect square. There's not a number that multiplies by itself and gets us 18. So 9 times 2, yes, that's actually what we want. What's the square root of 9? Because really what we're going to do, and what the calculator does to simplify this, is it splits it up to the square root of 9 times 2. Square root of 9 is 3. We can't take square root of 2. So it'd be 3i square root of 2. Yes. The 30xs, the little yellow calculator, will do all of these here. It'll keep it in simplest radical form unless the number inside and the number outside get too big. The number outside gets over 4 or 5 digits, and especially if the number inside is bigger than 4 digits, it normally starts converting it to decimals. But that's it there. Questions on this here? We feel good about this so far. Because really at this point, all we've done is taken what we've done in 3-4, our I, and applied it to the square root method. So the problems that we couldn't solve before, where we had those negative, those non-real solutions, we have a method that works as long as it's in this form here where we have a squared term, we don't have a middle term. Because if we can use the square root method, we can solve these here. I believe this is the last problem on the first page, yes? Yeah. We want to find the zeros of f of x equals 4x squared plus 20. When we find the zeros, we're trying to find out what value of x will make this equation be 0. That's all it's saying. Because we're wanting to know what value of x is going to make 4x squared plus 20 equal 0. Yes. Because it would be tempting to try to graph it, and there's nothing wrong with that. But it will not intersect the x-axis. It's actually going to be above the x-axis. So we're going to use the square root method by first subtracting 20 from both sides. And we'll divide both sides by 4. Telling us that x squared is equal to negative 5. So that got our square term by itself. Then we would square root. Yes, square root both sides. Yep. So x equals plus or minus. The negative does come out as I, but the square root of 5 does not reduce. So it's x is equal to plus or minus I square roots of 5. Questions on this here? So this is kind of giving us glimpses of how we can solve these, how we can do these here. Questions on this so far? But we still don't have a method that works every single time. We don't have a method for solving quadratics. No matter what the solutions are, we can get an answer every single time. But chapter 3.5, we're going to start today, and we'll do it twice in this part, of a method that does work every single time. Because square root method worked in one of two ways. We either had an x squared term and no middle term, or x was inside of a set of parentheses being squared. Now, if we look at this one here, and I want to solve this one in particular, it's going to be a little different. I want to factor this here, this x squared minus 16x plus 64. Normally, we would get it equal to 0, but here, I want to factor this here in particular. This might seem a little weird that we're doing it this way, but this quadratic, x squared minus 16x plus 64, behaves in a certain way. Now, when we factor this here, there is no greatest common factor. So we have our two sets of parentheses with 3 spaces. Here, the third term is positive. So the signs are the same and match the sign of the middle term. So we have negative and negative. Only factors of x squared are x and x. Our factors of 64 are 1 and 64. 2 and 32. 3 does not work, but 4 and 16. 5 does not work, 6 doesn't work, 7 doesn't work, but 8 and 8 does. Eight and 8. And I'm going to check this off to the side. X times negative 8 would be negative 8x. Negative 8 times x is negative 8x, giving us negative 16x, which is indeed our middle term. Okay. Questions on this so far? Now, again, I will say yes, it doesn't make a whole lot of sense why we did this and why we factored it without it being equal to 0, because our zero product property does not help us at all. Because we do have two things multiplied together, but they give us 100, yes? Well, the number of numbers that multiply together give us 100. There's a good number because it could be 1 and 100, 2 and 50, 4 and 25, 5 and 20. We could have any combination. But there is something special about these two factors. They are so really, x minus 8 times x minus 8, I could rewrite this as x minus 8 squared. Because whenever we have something multiplied by itself, I can say that it's being squared. Yes? I have a setup now that can be solved by the square root method. Yes? Now, we didn't necessarily cover it too much, but this here, this x squared minus 16x plus 64, is a type of quadratic that has a special name. We call this a perfect square trinomial. And the reason they call it a perfect square trinomial is because when factored, it factors to a single set of parentheses that is being squared. It's a perfect square. And this is nice because if I can rewrite the quadratic as a perfect square trinomial, I can rewrite it as a single set of parentheses squared. We can solve this by the square root method. I can take the square root of both sides. Here, the left-hand side, the square root and square will cancel, telling me that x minus 8 is equal to plus or minus the square root of 100, which is 10. So the reason, again, this is nice is that if I can rewrite that quadratic, rewrite the quadratic as a perfect square trinomial, rewrite it as a set of parentheses being squared, we can start solving any quadratic. Last thing we need to do is solve for x, solve for our variable. We would add 8, telling us x is equal to 8 plus or minus 10. We're not quite done, but are there any questions on any of this so far? Now, before we say that we're finished, we just need to check one last thing. Can I add 8 and 10? Yes. Can we subtract 8 and 10? If we can simplify, we need to simplify. So we do. We will indeed have two different answers. Because our plus or minus is just saying that 10 is positive. We do have a positive 10 and a negative 10. But instead of rewriting two statements, we write a single one with plus or minus. So really what this is saying is that we have x is equal to 8 plus 10, or x is equal to 18. And we also have that x is equal to 8 minus 10. So x is equal to negative 2. The only times that we really will not simplify down is if the number that came out of that radical still has a radical. So if it left it as square root of 10, we can't just add 8 and square root of 10. We're done. Or the number that comes out of that radical has I, like we had on the last few, 4i. In either of those cases, we can't simplify. Or actually, there's a third case. It has I and a radical. Then we really can't add those two together. Questions? So do we see this here? So this is really the start of the first method that works for all of them, because if I can get that set of parentheses square, we can do the square root method and solve every single time and get an answer. But we won't always have a perfect square trinomial to begin with. There is a way to make it be a perfect square trinomial. Any quadratic. Completing the square is this method. This is the first method that we will go over, we will learn how to solve any quadratic by. Doesn't matter what it is. We can find the solutions for any quadratic. And there are several steps to this. And the first main step to this, I'm trying to remember if I have, yes, is getting this perfect square trinomial. This is the linchpin to this method, is making this perfect square trinomial. It's finding a value of c, a constant term that we can have that will turn this into a set of parentheses squared. And that c, that value that we need, is equal to b over 2 squared. This is the key piece to this method, is finding this value of c. B over 2 squared. That will give us the perfect square trinomial. Now for this first problem that they gave us, they told us that we have x squared plus 14x plus, they already listed it as c. Now the next question that normally comes, where do we find a? Well, a is coming from the general, or b is coming from the general form. Our ax squared plus bx plus c. A, b, and c are all coming from this general form of quadratics. And for us here, a is 1. B is 14. And C, we don't know yet. At C, we have to find it. Because we need to find a value of C that will make the x squared plus 14x be in such a form that we can rewrite it as a single set of parentheses squared. Now to find that value of C, we're going to use this formula here. C is equal to b over 2 squared. C is equal to b over 2 squared. Well, our value of b, we already said, is what? 14. So C's value is going to be 14 over 2 squared. Now, at this point, we could type the whole thing into the calculator, let it do it for us. The thing I would suggest, and is going to be very helpful, is to divide 14 by 2 first. Divide what's inside first before applying the square. Here, 14 divided by 2 is 7, positive 7. And if we square 7, we get 49. So the value of C that would make this a perfect square trinomial is 49. Telling us that our quadratic, our perfect square trinomial, is x squared plus 14x plus 49. That's our perfect square trinomial. We have one last step, because then it wants us to then write the expression as the square of a binomial. Factor it. Factor it to a single set of parentheses squared. Okay? Now before we do that, are there questions on what we've done so far? Now to rewrite it as a set of parentheses squared, because that's kind of what we did on the last one, we could do our normal factoring steps, our 2 sets of parentheses with 3 spaces, find the sign, and go from there. But there is something that works very nicely with this here. Because our value of C, this 49, we found it because it's going to rewrite this as a single set of parentheses being squared, yes? So this will factor to a single set of parentheses being squared. The first is going to be that x. It's going to just be x. And this comes from part of our steps with completing the square. And all that leaves us with now is the sign and the number that go in there. It would be 7. And what I find really interesting is that the number inside the parentheses before we square it, for us finding C, will be the sign and number that go inside our parentheses for this here. Yes, so if the number inside the parentheses was -7, it would become x minus 7. So the process of finding C really gives us the other half of the factor that we need. So since it was +7 before we squared it, it's going to become x plus 7 squared. If it was -7, it would be x minus 7 squared. That's why I said it's good to do the division first so we know what goes in there, what's going to be part of that answer before we square it. That's it. So this is the first part. We're doing this here before we get fully into the completing the square method so that we have a foundation of finding C, finding that third term before we get into actually using it. All right, we're going to do this a few more times. Now, luckily, I think your note sheets have this spaced out a little better than mine. Mine are all right next to each other. So,
Could you remind me what to click on the calculator to make a fraction?
alpha y equals enter. Yep. I would say, especially for those of you who are taking the ACT tomorrow, because I think some of y'all are, you are allowed to have both. You're allowed to have the 30XS and the graphing calculator. For some of it, it's easier just to type it in the 30XS than it is to type it in the graphing calculator. And if you do feel comfortable with using the graphing calculator on the test and you want to use it, make sure to stop by here before breakfast or as you're going to breakfast to grab one on your way up. If you don't feel as comfortable with it, I wouldn't mess with it. Some of this, yes. So again, the biggest thing I'd say, especially for tomorrow, is just don't leave anything blank. Relax, do your best on it, because there is some of the math material we have not covered.
If it ends up like the pre-ACT.
So again, I just wouldn't leave anything blank, because if you aren't sure, if you read it 2 or more times and not sure what the question is asking, mark that you're guessing, pick a letter of the day that you're going to guess every single time, guess and move on. Because leaving anything blank is the same as getting it wrong. Because for your grade on the ACT or how they score the ACT is based off the number of correct answers. Not your incorrect do not take away from your score. So you have that there. All right, so we will provide the yellow calculators for y'all. Grab a graphing calculator if you feel comfortable with it. If you don't, I wouldn't mess with it because you're going to waste more time trying to figure that calculator out than you would actually on the test. Let's look at these here. We want to find the value of C so that we can rewrite this as a single set of parentheses being squared. Now for us here, C is equal to B over 2 squared. And B in our case would be 8. A is 1. So we can plug 8 into this here. Yes. Because our 8 divided by 2 is 4. And 4 squared is indeed 16. Telling us that we have x squared plus 8x plus 16. So we plug our value B, 8, into this form here. 8 divided by 2 squared. 8 divided by 2 is 4. And our 4 squared gives us 16. Since we have positive 4 inside the parentheses, when we go to factor this, we would get x plus 4 squared. Because we take the number and sign before we square it to get our factors. There's our final answer. Questions on this here? Let's look at the next one, x squared minus 2x plus c. So we still need to find the value of c. Well, c is still equal to b over 2 squared. Now looking at number 5, a is still 1. B is now what? Negative 2. And we're trying to find c, so b will plug in as negative 2. And again, we could plug this in, parentheses, negative 2 over 2, close parentheses, squared. I think it's better, especially with factoring, to divide first. Negative 2 divided by 2 is negative 1. And negative 1 squared is 1. And so if we plug that value of c back in, we get x squared minus 2x plus 1. Yes. So when we go to factor it, we'll have our two sets of parentheses, our set of parentheses squared, x. And since the number inside the parentheses before we squared it was negative 1, it tells us that this will factor to x minus 1 squared. So we'll need both. We'll need the quadratic and the one there. And if you're wondering, yes, the value of c is always going to be positive. Yes, because whenever we square a number, it's always going to turn out positive. So our last one, or number 6, x squared minus 9x plus c. Here the value of b is negative 9. Negative 9. All right. Negative 9 divided by 2. Does it divide evenly? Yeah, it's negative 4.5. We get a decimal. For this here, it's going to be neither here nor there. When we start using this, especially in completing the square, it's going to be better to leave it as a fraction than it is to turn it into a decimal. So we'll leave it as negative 9 over 2. We're going to square it, which is going to give us 81 over 4. So we have x squared minus 9x plus 81 over 4. So our quadratic, our perfect square trinomial, and then we get this here. And since negative 9/2 was inside the parentheses before we squared it, it factors to x minus 9/2 squared. Questions on this here? Questions on anything we've done so far? How do we feel about finding c? Do we see how this works? That's my wife's reaction to jokes like that at this point. Shown. At about halfway down the page for these next two, have you write these down. So you won't need the full page for either one of these problems, but these here are the 4 steps for completing the square, the completing the square method. The first main step, is a equal to 1? If not, make it so. Step number 2, get all the constant terms away from the variables and leave 2 spaces. Essentially what we're doing is we're getting the constant term by itself. Our number without a variable is going to be on one side. Our variables are going to be on the other. 3, find the value of c equals b over 2 squared and plug it in. Find the perfect square trinomial, factor it, and solve. So the perfect square trinomial is our set of parentheses squared. Our perfect square trinomial is that set of parentheses squared. So all that step is saying we get it rewritten as a single set of parentheses being squared, and then we solve by using the square root method. The fact that this works is interesting. The fact that it works every time is what makes it worth the attention that it's gotten, or it gets. Because up to this point, this is the only method that we have, or we've gone over, that works for every single quadratic, no matter the setup or equation that we have, or the solutions that will come from it. Did we get these down? Okay. Anybody still writing?
Yeah.
So, if we look at this one here, I'm going to rewrite it mainly because I'm just wanting to rewrite it. You don't have to rewrite it. We're just looking at the one on top. Step number 1, is A equal to 1? Because when we're talking about A, it's our ax squared plus bx plus c. We're really asking, is A equal to 1? Is the number in front of x squared 1? Yes. If it isn't, we have to make it so. Step 2, get the constant terms by themselves. So we need to move the 7 over to be by itself. And to do that, for this one here, we're going to subtract 7 from both sides. Because our second step, get the constant term by itself and leave 2 spaces. Now, the getting the constant term by itself makes sense, but leave 2 spaces. We put 2 spaces in here. Now, the reason we leave 2 spaces is because, again, we need to find C. We need to make this perfect square trinomial, like we did with the last few examples. Because that value of C is going to go in there with our x squared minus 10x to make that the perfect square trinomial. Questions on steps 1 or 2? We feel good about steps 1 and 2.
Oh, yeah.
Step number 3, find the value of C, which is equal to b over 2 squared, and we're going to plug it in. Now for us here, the value of b is what? Negative 10. So the first thing we want to do is take negative 10 divided by 2, which is negative 5. And negative 5 squared, negative 5 times negative 5 is 25. So we'll plug it in here, giving us x squared minus 10x plus 25, which is our perfect square trinomial. But if I add something to one side, I have to add it to the other. That's why we leave 2 spaces. We leave the space so that when we find C, we can put it into both sides, and our equation is still equal. That takes care of step number 3. We ready for step 4? So, first part of step 4 is we need to factor our x squared minus 10x plus 25 to be a single set of parentheses being squared. We'll still have the x. And the number that goes inside this parentheses is still whatever the number we had in the parentheses when finding C before we squared it. Since it's minus 5, it tells us that this factors to x minus 5 squared. Questions on this here? The other side we can simplify. Negative 7 plus 25 is 18. You're good? And this is, again, as we see here, we started off with an equation using this method we were able to get it to a single set of parentheses being squared equals a number. Now we can solve. By first taking the square root of both sides, because here the square root and square will cancel, showing us x minus 5 is equal to plus or minus square root of 18 is 3 square root of 2. Luckily, since it's not negative 18, we don't have I. It's just 3 square root of 2. Then we'd add 5 to both sides. Yes? Whenever we add or subtract a number from both sides at this point, we want to put it in front of the plus or minus. Yes. Can we add 5 and 3 square roots of 2? Well, the square root of 2 is 1 point, it's a decimal, non-repeating, non-terminating, yes? Do they both share that same radical? We can't add them without turning it into a decimal. So, that's as far as we go. Now, especially with this here, if it has I, the 30xs just can't do it. But you can try, especially in the 30xs, plug in 5 plus 3 square roots of 2. If it gives you a single number, then yes, we can add it. But here, it's just going to give you back 5 plus 3 square roots of 2, or 3 square roots of 2 plus 5. We can't add, we can't simplify it to a single number, so that is the answer. Questions on this here? So we're going to dig more into this. We're going to do more with this completing the square method. But the homework for this is 3, 5, 11 through 18. So 3 and 5 are going to be just like the first one we did. We can rewrite that as a single set of parentheses squared and go from there. But the main part of this is 11 through 18, finding that value of c to get our perfect square trinomial and factoring it.
3, 5, 11. We're stuck on.
If you get stuck on 3 and 5, that's fine. We can do them together in class. I can go over them. But